some presentations from the two of the hackathon winners from the hackathon in, is that in May?
April.
April. Thank you, Pablo. Yeah, so thank you all for coming here. I hope you enjoyed some food. There's more back there, so please eat up. Thank you, Amelia. Yeah, so we'll have some talks. We'll ask them some questions. If we didn't ask enough questions during the talks, we have 2 talks today, and then we will chat and eat some more. So we always want to thank our generous sponsors, including the UCI Paul Mirage School of Business, who's been a long-time sponsor for which we're grateful, as well as the UCI Master of Data Science program.
Which I think both winning teams, are you from UCI?
No, we are from Cal.
Oh, okay. Yeah.
And from UCI.
UCI, all right.
All right, so if you want to find us, we exist all over the internet in some various places. Yeah. And we have a speaker for July.
We do.
We're going to roll it out right now, but we are, or unless you want to. Yeah.
Yeah, we have someone confirmed. She's a professor at Chapman University. I'm going to butcher her last name, so Chelsea is her first name. But she is teaching a course on how to use Shiny for Python users. Now that there's like an alpha and a beta for Shiny on Python, and Python's version of Shiny is also sort of advanced in ways because it could use WebAssembly to do like purely client-side kind of serverless Shiny applications. So it'll be pretty interesting to hear her talk, and hopefully bring out some people that are doing dashboarding or want to build web apps with Python.
Yeah, it should be a great talk, and she's giving it also further afield to a bigger crowd, so you should feel very lucky that she's going to give it here as well. But if you guys have any ideas of people who you think might be a great speaker, or if there's something you particularly want to learn about, feel free to let us know, and we can try to find someone who would fit that niche. Yeah. So we have 2 groups talking tonight. Thank you both so much for coming out. And first we have the team that won the best insight. That was Team Runtime Terror. We have Ruchi and Chakopani talking, who are recent graduates from Cal State Long Beach with their Masters in Information Systems. And their project focused on finding data anomalies that would go mostly unnoticed while performing data analysis. And so they won the Best Insight Award. And then after that, we have the Best Presentation Award. So Team Runtime Terror is here. Kushal, Ravali, Karan, and Rahul are here. Kushal is a passionate data enthusiast with a strong background as an analyst, accumulating valuable expertise over a span of 3 years. He's pursuing his business analytics from UCI and seeking new opportunities, so talk to him if you know about opportunities. Ravali is currently pursuing her Master's in Business Analytics at Paul Mirage, and she recently joined Cardinal Health as a financial analyst intern. Karan is about to graduate from UCI with a Master's in Business Analytics. He's a talented data analyst and visualization expert. And Rahul recently graduated from UCI in Business Analytics and is an aspiring data analyst. He's also looking for a job, so talk to him if you know about any opportunities. And so with that, thank you, and we'll start with Team Runtime Terror. Perfect. Did I mess up? I did.
It's okay.
No! I messed up. Did I mix up names? No, worse.
I think it was Ruby.
I just left the group, that's it. But we'll fix it.
This is Team Outliers, even more exciting for us.
So hello to everybody present over here. First of all, thank you so much for having us. Thank you so much for arranging everything so that we could be here and be a part of explaining our solution to all of you. I quickly wanted to mention some, fun small things. We're outliers. The reasons we called ourselves the outliers was because we were 4 girls and 1 guy who was an outlier. So that's why. And then we came here, like I came with 2 of my friends from CSULB, and we met 2 really amazing people, Madhvi and Yife from UCI, and the 5 of us became a team, and we were the outliers. And so basically we're gonna, this is the agenda, we're gonna go through these things: the introduction, the problem statement, the approach to our journey, the code, the insights, and the conclusion. So I would love to get started with the introduction first. So that's Chakrapani, this is me, and then Priyanka, Madhvi and Yife, they couldn't make it today because they're all, I believe, unavailable or out of state. So, but best wishes from them. And then we're gonna just introduce ourselves really quickly for you guys.
Hey people, thanks for having me here. And good to see familiar faces again. So myself, Chakrapani Suresh. I graduated recently from Cal State Long Beach with a master's in information systems. My strong skills are SQL, Python, statistics, Tableau, and Excel. So I'm fully packed for data analysis. So my interest in data analytics is I believe I can call myself a data detective because I have a special eye for looking for trends, patterns, and insights, and that's the whole idea of how we won the hackathon. So that's a little background about myself. I'll hand it over back to her.
So my name is Ruchi, as you all know. I'm basically extremely passionate about analyzing all sorts of data. I've tried financial data, HR data. I just have fun with data. That's kind of my way to go. We also wanted to mention both of us are actively looking for full-time positions. So if anyone has any opportunities, please do let us know. Those are my points of interest. My strong skill suit is also Python, SQL, R, Tableau, and Power BI. I dabbled into app development, web development, and robotic process automation as well. I've got papers published under those as well. And in my off time academically, I like to work on data related projects. So now we would like to move on to the problem statement. So basically, we were just supposed to do anything that we wanted with the Yelp data set. We were given a portion of the Yelp data set. We could also work on the whole data set if we wanted to. The problem statement that we finally concluded to was telling Yelp about insights that could be anomalies while other people perform their data analysis. So basically, the reason why we chose this particular problem was because, as you can see, according to a survey that was performed by Oxford, the top 3 errors during any sort of data analysis, obviously there is duplicate data, but another one of the biggest ones is data anomalies, which is any kind of inconsistency in a data. So we wanted to basically make sure that we don't that we find insights that correlate to that. The reason for that was so the reason for that was basically the approach to our journey. So initially we wanted to find out, our problem statement was supposed to be something completely different. Initially we wanted to find out the best place to open a bar, and then we realized that after spending some time with our data set, we realized we didn't have enough points to analyze it in the way that we wanted to analyze it. So we spoke to some mentors, we re-evaluated our entire strategy, and they said that we just need to find a basic problem and work on that. So we thought, hey, you know what, let's just work on the problem that we are facing right now, which is going too deep into a data set and then realizing that you don't have enough or there are inconsistencies. So we stuck to the inconsistencies bit, and then we tried to find insights on inconsistent data itself. Just try to find like different kinds of anomalies. And that's how we came to our final problem statement, which was telling Yelp about data anomalies their data analysts could face when they analyze their data set. So Chakrapani is going to talk about the code right now.
Yeah, so when the rules were announced, what got us more excited was the judges came and told us that we can just use anything to do your data analysis, even if it meant doing it in pen and paper. So we thought, the opportunities are a lot now because there's no constraints. So, we wanted to keep it simple. We didn't wanted to do a lot of complex code. We just wanted to do pure, clean data analysis and find the best insight out of it. So, as usual, initially when we got the data, we used Excel to, go through the data to see what we are dealing with. And then we did our initial exploratory data analysis, cleaning, just using basic filtering and sorting to get our data ready. So step 2, we needed some advanced tools to get our data ready for visualization stage. So we used Python. So basically we kept it simple in Python. So of course we read the data because it was a huge data set, and then we just used 2 joins to join the data. So the first join was an inner join. So basically, we were given a user data set and a business data set. We had to merge them both so that we have the reviews of the user per business that we have. Let's say there's Hotel X. We want all the reviews from all the users for that user. So that's the first join we did to prepare our data. So once we had that data frame, we performed a left join based on user ID. So now we have this final data set that has all the users and all the reviews they left for all the businesses and how they were rated, were they funny, were they useful. So we had our final data set here for processing.
Quick question, do you want questions at the end of your presentation, or do you want us to raise your hands like in the middle? It's up to you.
We're fine with both. Yeah, I think.
Okay, I have a quick question then. You said they're big data sets. How many records are we talking? Or what's the dimension roughly?
Let me take a look at that.
It's okay, you can keep going to the present. I was just curious if it was like millions of rows or hundreds of thousands.
I think it was 2 gigabytes.
2 gigs?
I think it was small enough to fit in an Excel file, but big enough that working with Excel to do anything was a problem.
But then, so what happened was when we basically joined everything, right? So we joined a user and how many reviews the user has given. So it just became like bigger than we thought it would be. And I'm not entirely sure, but I believe there were at least like 100,000 rows in our data set.
Okay.
So yeah.
Thank you.
So yeah, that's all we did using Python, just some joins to get our data ready. Since we were looking for the best insights out of it, we thought using Tableau or any visualization would tell us the best story. So on to the next phase with groups.
So basically, we were, so basically we're just looking at some of the insights that we got, that we presented over there at the, hackathon. So now in general, anyone who is, looking at insights would assume that the funniest reviews are reviews that are like the bad ones, like bad reviews, but like that are horrible in a sarcastic way, just mean in a funny way. But that wasn't true according to what we saw. The data set, the funniest reviews were the ones that had 4, 5 or 3-star ratings. In fact, 1 or 2 stars were actually the ones that were lesser funny, like people found them less funny. So that's something that, I just feel like this matters, because in case someone performs data analysis to correlate funny reviews to bad ones, and that's one of their key points to getting a result, they could be wrong. And that's why we believe this is, a data anomaly. Then we analyzed whether the most impactful reviews were written by the most experienced users. So we found that the users with the most experience on Yelp were the ones that wrote reviews people found most useful. And then we also wanted to see whether the number of reviews made by a user is directly proportional to a user's age on Yelp. So Yelping number is basically how many number of years a user has been on Yelp. So basically we found that in our category, the people who have been using Yelp since 19 years don't have a high review count, which means they haven't posted that many reviews, which also takes us back to our previous slide where we found the oldest Yelp user made the most useful or I'd say most impactful reviews, which is a great insight, because contrary to popular belief, more quality of reviews don't mean better, more quantity of reviews don't mean better quality. And then after that, we basically started, finding out whether the most useful review was made by the most useful user, and that wasn't true. The user that had the most number of reviews reacted to as useful was not the user which had a review that was found to be the most useful out of all the reviews. Similarly, we did the same for like the coolest or the funniest, and the reason that the reason because of which this matters is because there were some groups that presented with us, and they tried to predict if a user is fit to be a part of the Yelp Elite Squad. To do this, some of them said that the user is that the user with the most number of multiple useful reviews is qualified to be a part of the Elite Squad. However, they all left out of consideration the user with the review that was found most useful. Both these types of users were different, and that's something people would not know without performing an exploratory data analysis to find such anomalies. So that was basically our approach to this whole data set, and we found very insightful things, and we're grateful that everyone found them insightful as well. And we'd like to, ask what you guys thought of it. And yeah, thank you for listening to us. If you guys have any questions, we'd love to answer them.
I was having a little hard time seeing the axis labels on your graphs for that y-axis. Is that the average? Is that a count? I'm trying to figure out what exactly you're plotting there.
For which graph?
So something like this, right? Or on the left graph, you seem to have reviews, and the right graph is users, and I can't read the axis labels to figure out what exactly is being plotted.
So we were just trying to find out which review got reacted to. So in this graph, we were just trying to find out which review got reacted to as the most useful review out of all the reviews there were in our data set. And versus the age of the user on Yelp, like how many years someone has been using Yelp since.
Okay.
That's what we plotted.
So each dot is a user?
Yes, yes, because we basically sifted it on the basis of user ID. So each dot is a user.
Okay, and then what is the y-axis? Is that the number of useful reviews? Is that the average?
No, that's the review. So that's the review that was reacted to as the most useful review.
Okay, so
the number of people that reacted to a certain review saying it's useful. So let's say there were 2 reviews, and review A was reacted by 50 people saying it's the most useful. Review B was reacted by 20 people saying it's useful. So like 50 becomes the one that's most useful in that sense. So that's how you're plotting. I know the column names are definitely confusing. It's the same image that we used back during the hackathon. Everything was in such a rush, so we just used the column names that were given by Yelp, so we didn't have time to change them. But that's pretty much what it was. Is there any other graph that I could explain to you?
So what's the difference between the 2 graphs?
So the left one, okay. I guess you can't see it on clearly, but basically the one on the left is a useful user. So there was a column in Yelp called useful user in the user table that basically said how many of a user's reviews were reacted to as useful. And that's what we plotted against, again, their Yelp engage. And that's the difference between 2, where we basically found out that a user that has written like multiple useful reviews is not the same user that has a review that's found the most useful by all people on Yelp. And most people, you know, leave facts like these out when they're trying to classify somebody to be a part of an elite squad or not, and that's basically an insight that we wanted to point out, to not, you know, leave these kinds of things behind when you're performing your data analysis. So yeah.
So the x-axis is not the age, it's the number of years they've been on Yelp.
Yes.
Because that wouldn't make sense of a 1-year-old.
Yeah,
actually
like,
had a Yelp review, right?
Yeah,
So,
like
okay.
the Yelping age.
Yeah, so basically the highest reaction count is happening for roughly a 14-year Yelp user.
Yeah.
That's what I'm reading, okay.
Yes.
Because it's possible, you know, 19 years helping age is like the early stages of help before it was popular.
Mm-hmm.
So we believe around 14 years of help age is where people started using it more.
Mm-hmm.
Are there any other questions that?
I have a quick one. In a previous graph, you were mentioning a funny review, right?
I think
One of the first ones. That funny review, is that something that was provided in the data set, or
Yes.
was that something you...
Yes, there are 3 reactions on Yelp. They're useful, funny, and cool. So for all of them, for the user data set, there was funny, cool, and useful. And then for the review as well, there was a useful, funny, and cool. So we basically used both of those different, you know, data sets, combined them into one, and then categorized it this way.
Got it. So there was no overlap between, like a review cannot be both useful and funny?
No, it's kind of like the React you do on LinkedIn. So you can either like, support, or celebrate.
Okay.
It's something like that.
Got it.
So you can do only one kind of React per post.
Got it.
So what were you using to make these graphs? I mean, these graphs are beautiful, and also your other slides were also beautiful. What did you use to do that?
We used Tableau to make these graphs, and for the slides, I just used a template because I always like making slides with templates.
It's really nice.
So, yeah. Thank you.
Is that where you also did your DBA, or were you exploring the data in Tableau as well, or were you just making final graphs there?
Kind of both. But yeah, we kept Tableau for final insights and presentation. But also on the way when we were, you know, we just randomized all the graphs. We just took some elements, made at least 20 graphs to see if we can find anything useful. And these are like the most useful graphs that we found. We scraped the rest.
So when we decided that we're going to, you know, focus on specifically inconsistencies, we started plotting as many, you know, different kinds of things that we thought could be inconsistent or give us a result that could be inconsistent. We actually plotted graphs in Python. We also did EDA, like he did EDA in Excel, and you know, then we ended up doing the final ones in Tableau because Tableau always helps us give a better presentation to things. So that's why, yeah.
So earlier you were talking about how you cleaned the data and then you did an intermerge on, what was the name, like user?
Yeah, the
Business ID and then, I'm sorry, Ruchi? Okay. You mentioned that like, eventually it almost kind of like imploded because there was a lot of reviews under one user, right? So, was there a point where like you just cut off the data, like no, we're only gonna use users that have X amount of reviews to make it, or you just still took everything?
No, we just did everything because as we realized with the Yelp data set, the shorter version that was provided to us for the hackathon, most of it was restaurant.
OpenAI, I gave it a prompt, so you know, consider this restaurant and search in Google which is the 3 dominant cuisines served in this restaurant.
Oh, gotcha.
So I got a result like probably two or three as per its you know, understanding. It just gave me those cuisines. So based on that,
5 minutes?
yeah, it took me around 5 minutes.
Oh, great.
Yes.
And see, there's a potential risk because in the provided data set, there is no cuisine or menu recorded. that means OpenAI can make up something, for the...
Actually, we have the categories column, right? There, the data was not very appropriate. There was a lot of dirty data, but on that, it was clearly mentioned. Some places it was about Indian, Chinese, and all of that. There was a lot of junk associated. We compared the category output with the OpenAI output. It was somewhat matching. So we did that cross-check over there.
Yes, any more questions?
I'm just curious if you considered like using transformers or something as opposed to word to back or.
No. Did we? No. We had experience in Word2X, that's why we didn't want to like try out different things at that time. But
given the time constraint.
Yeah.
Because we actually took a lot of time to decide the topic itself. We spent like around 30% of our time, just focusing on topic. Yes. So that was actually a pretty good exercise for us, I would say. As Team Outliers also mentioned how they came up with that topic. We had a very good approach. I believe it was a very good approach. So we basically divided all of our topics into, if it will be helpful to Yelp as a company, if it will be helpful to business, or it will be helpful to users. So we had these three topics divided, and whatever we were coming with topics, we were deciding where should we fall this in. So which will have more impact. As if if we sell this idea to Yelp, they can implement this in their website. Will it help them increase revenue? Or since this identifying hidden gems is a customer centric. So we wanted to identify such topics which will be either business centric or customer centric. But all of us believed in having a topic which is customer centric is more useful. Going forward, if we sell this idea to customers, we can have more revenue. But I know we can have it with respect to business as well. But I wanted to build something for customers, so that is why we decided this. Decided on this idea.
Yeah, and we had like a couple of foodies as well in our team. So
All of us.
Is your code online?
No. We can upload it on GitHub.
Yeah.
On the
What was your team name? I missed it.
Runtime. So I don't know why we kept that, but we like that name, so it's not related.
I might just call you foodies.
Perfect.
Thank you all so much. That's very impressive.
Thank you. Good job, guys.
So great.
Yeah. Thank you guys.
Is that everything?
Pretty much it. Yep.
Related data set. So we just focused on that, and even within that it was still a lot. So we actually did not use like Excel files or anything as such. We just did it on Python. So since we didn't actually have to open the file, it didn't give us a lot of issue. So we just decided to use the whole thing.
Okay, one last question.
Yes.
So what did you, so you said that you had 20 or so different graphs. What did you learn about either like how to quickly find good questions, or what did you learn about doing this sort of DBA that, so you identified a fair number of things that you want to warn analysts about, but if they were on their own or on a different project, what would you tell them about what you learned about the whole DBA process, about how to get these insights themselves?
So yeah, mostly we concentrated our EDA on credibility of the data. So what we didn't consider is the graphs that didn't really address anything meaningful regarding the reviews or ratings. So if I remember, we had something like the helping age versus the number of reviews they left. I mean, at the start it sounds insightful, but the graph didn't say a lot when you compare the age versus the number of reviews.
So I think what happened, like what he's trying to point out, was the fact that we, on the board that was given to us, we wrote a lot of questions, because like it's just, we were brainstorming because there were 5 of us, so we were easily able to do that, and we wrote tons of questions, and questions we thought were going to be like, oh, this is the insight, you know, that we want to find, that ended up being not that great of an insight actually. So that's basically what he's referring to, that we had to like sift through so many things that we thought would be useful, but they ended up not being useful. So I think what we're trying to say is that the approach that you think you're going to take is not always the best approach. So it's always good to have many other multiple approaches in mind, so that you at least you know, reach to some sort of solution to the problem statement that you are trying to approach.
Thank you so much.
Thank you so much.
So hi everyone, we are team Runtime Terror, and by the way, let me start with asking one simple question. How many of us love food over here? Okay, so everyone. So yeah. So I myself am a big foodie. So last week I was in San Diego. We were visiting beach and partying. While coming back, I was trying to find a good place to eat, but it was pretty late, so it was not easy to find one. But thankfully, while coming back on the way, we found one and we visited that place. The food is really amazing. And while exiting that place, we tried to give that restaurant a review on Yelp, but sadly we saw that there were very few number of reviews for the restaurants. So I'm visiting Santa Barbara next week. So can you suggest me the similar places that was found by me in San Diego?
So you know the scenario which my friend Rahul mentioned, you know, we call this process as hidden gems. You know, so you might ask me, what is an hidden gem? What is a place which a foodie looks for? So the exact sentence which he mentioned, you know, he loves food, but he doesn't know which restaurants to visit because Yelp does not have those restaurants in their place, because it might have, you know, low ratings, or there are not much reviews on that. So this type of restaurants, we call it as hidden gems. And foodie likes us, we want to explore these places. So this is what we are trying to solve using our data set. So welcome, this is our team, Rahul, Ravli, Alekhya, Karan, and myself, Kushal. So, you know, our problem statement is pretty simple. We are trying to discover hidden culinary gems through a data-driven recommendation system for food enthusiasts. And thanks to Team Outliers, they were pretty much able to explain the data which we had. We had, you know, 3 data files with us. The first dataset file which contained reviews of business. So we had, I would say, approximately 350,000 reviews with us, and we were able to just, you know, take out only the California reviews in that. So basically the restaurants are the places which have California reviews in them. And the second data set was, you know, of the California Yelp users. So we had around somewhere 5,000 California Yelp users in that. And coming to a third data set which we had of California business, we had somewhere around 150,000 California businesses which were in Yelp. So we were able to have this 3 data set and we merged them for further analysis. And now my friend Ravli will explain you the path from data to insight.
Thank you, Kushal. So basically, like Rahul and Kushal had just mentioned, we tried to research on the characteristics a foodie can have. So what characteristics a foodie will look for when he is reviewing a dish or something from a restaurant. That is our first step. Then we of course did the data cleaning and feature selection. And then we did the sentiment analysis and then word embeddings, and then we have used OpenAI as well. We'll talk in more details about that moving forward. So these are the qualities that we identified. So of course the food quality, authenticity, uniqueness, creativity and presentation. These are the 5 things that a foodie usually rates when he goes to Yelp or any platform while reviewing a particular restaurant. So data pre-processing, like Kushal was mentioning, we only filtered out California reviews, and then we joined users file with the business file and also the reviews file. That's how we created a complete data set. And then we filter out only the currently active businesses. And then we added a new column called newness, because we wanted to know the age of a particular business. So we calculate the age from 2022 till the first review that was posted for that particular business. And then we take all the businesses that are of age less than or equal to 10. So we filter the data and moving forward. So I think Karan will talk more
Thanks,
about
Ravli. So now that we've pre-processed the data and we have the data ready to do our modeling part, right? The first step was to identify the cuisines that we wanted to, like a foodie goes, looks for a cuisine in a restaurant that he wants to try out, right? So that is the first thing that we wanted to filter our data with. When we looked at the data, first thing we noticed was the column that cuisine was specified for a particular business had a lot of values in it. Like usually a restaurant caters to a lot of cuisines, right? So that is why we wanted to clean it first, wherein we've used OpenAI API to get the most common or the most predominant cuisine of that particular restaurant. Once we had that, the next step was to filter out the reviews, wherein the characteristics that Ravli had mentioned earlier were being talked about. So for that, what we did was we used word embeddings. What a word embedding does is, it's a dense vector representation that captures semantic relationship between words. What that actually means is, it just gives you a relationship or a similarity between two words. So here we've used word-to-vec algorithm to do word embeddings, and the process what we followed here was we gave our review corpus to the word-to-vec algorithm, and we allowed it to train on it. Once it got trained, it gave us a sparse vector representation and a dense vector representation which had similarities between words. And since we know that these were the characteristics that the foodie looks for, we filtered our reviews based on those the characteristics. Once we did that, we had all the reviews that we wanted which were talking about those characteristics in a restaurant. Now, what they were actually talking about is what we wanted to check out next, wherein we did our sentiment analysis. Now, for sentiment analysis, there were many ways we could have explored that. The one way that we explored was Vader sentiment, just because of the time constraint and it's pre-trained. So Vader, why we chose Vader was, Vader usually works good on social media data. So that's the reason why we chose Vader. And we gave our data or the reviews that we had collected to Vader, we passed it through it. Post that the Vader algorithm gave us polarity scores for each review. Once we had those polarity scores, what we did was we aggregated that at business level, and we got an overall polarity score for that particular business. And that was our final data set. Sorry, before that, what we did was we also, once we got the overall reviews, we filtered out the negative ones, since we only wanted to focus on the positive things or the positive businesses, since that just indicates the positive or the good vibes that are present in that restaurant. So having all this data, having all these hidden gems that we had identified, we inputted that to our Tableau dashboard. This is what we had created, an application of a sort to users like Rahul can use it as a foodie, right? So the filters that we had selected here were city, just to select the city that he wanted to visit or look at the cuisine that he wanted to go and eat in. So city and cuisine were the two main filters that we had put, and so let me just play that. Yeah. So here we just have a video of where we are specifying these are all the hidden gems for cuisine Italian that he can visit to in Santa Barbara. We have also specified the number of stars that a particular restaurant has, the top review according to us, according to all the filtering that we had done, what is the top review, and also the address of that restaurant. this is something that we had created and a user like Rahul can use. So yeah, similarly for other cuisines as well, we've just taken a video and shown you what the output is going to be. And I think yeah, so just the next steps. Now that we were confident on what we had delivered, but given the time constraint, right? But if we had more time, these were the next steps that we were planning to do. One was the consistency check, wherein we could have done a time series analysis to check the business with consistent positive feedback and a strong track record of delivering quality service, since that is also an important aspect in a restaurant. And the second was the freshness check, wherein the newer reviewers and the recent positive experiences can indicate that a business is consistently maintaining its quality and appeal. So both of them are like overlapping, but yeah, these were the two things that we would have done if we would have more time, and alas we didn't. So yeah, that's it from our analysis. If you have any questions, we are open to it.
Yeah, so I see where the gems is coming from, but can you talk a little bit more about how you define hidden in the analysis?
Sure. So it's basically hidden because it's not coming up, on the top. When we open the Yelp app, we have, the top rated restaurants. So if you go towards the first or the second page, you can see the restaurants which are highly rated, which have more number of ratings, which have more number of reviews. When I say hidden, it's just that they're down in the listing. They are in the 4th or the 5th page. Where, if I'm searching for a restaurant, if I want to go to, a pub or something, I'll usually restrict myself to the first 3 pages. I won't go towards the 5th or 6th one, because I'll be like fed up. Oh, come on, man, I'm done with it. So this is what we're trying to identify.
In the data cleaning to kind of guess which restaurant, or maybe it was in the data set, which page these things appear on?
So basically, in terms of cleaning, yes, we did cleaning. We were only focusing on the restaurants which have, which does not have much number of reviews. So that is what we were focused on. Because if a restaurant has higher number of reviews, it will automatically come up, on the top pages of Yelp. So this is what we are focusing on. Like, it has less number of reviews, but it has good star rating, and which are operational for like 10 years. So this is what, because as a restaurant opens, if I'm opening a restaurant, I know my friends will give good reviews to that. So even the food might not be good, but they're going to have much good reviews on that. So we were focused on restaurants which were like open for 10 years at least. So that will have, good analysis. Yes.
Was there a specific reason why negative reviews were, exempted from your analysis?
Yeah, so I'll take that one. So usually negative reviews won't mean that a person is going to go to that particular restaurant, right? So just to clean our data and just to make the data set smaller, that is why we just exempted those out. Yeah. So overall, so one thing to notice, we exempted those negative reviews out in the overall score and not initially. So once we had the negative score at a business level, that is when we excluded those businesses altogether.
So just to add to this point, we made a polarity of a particular business. If a particular business overall polarity was negative, that is when we excluded that business out. It's, we did not actually remove out only the negative reviews, but if a combined score of that particular restaurant, of a particular business is less, we are just taking out that business from our data set. Yes. Next, you had another question. Yes.
I was just going to comment. This would be an awesome, web app or something like that. Website that you could log in and put whatever city you want and see the top hidden gems within a certain cuisine. Yeah.
Sure, we'll try to explore that, and I can host it somewhere.
On your Tableau dashboard, you had, when you click or hover over the dots, you had certain reviews, I think.
That was the top review that we had identified when we were doing all of this analysis, right? We had identified the polarities of each review. So we just put in the top review that is going to help. That is going to be most helpful for that particular user.
Got it.
So I'm a little hung up on the foodie term. This is just because of how my brain works. When I think of foodie, I think of not common ingredients, right? Radicchio, endive. I also work in agriculture, so it helps that I know like 500 types of lettuce, right? But I'm wondering, considering you used OpenAI to do some scouring of the reviews, would it make sense if you were to say make this a Shiny app or some kind of web application to use OpenAI to identify maybe not common ingredients or entrees that are named after French cuisine, right? Because that happens a lot with food. Even if it's an American dish, it tends to have like a French kind of play on it. So just food for thought, really not a question, just kind of a comment. I guess one question I do have though, if you could have had another data set to help supplement your analysis that would have made this much more enhanced or easier, what would that data set have?
You know, with the introduction of OpenAI, it's limitless. I can actually make anything. So yes, if given a data set, if I have a particular restaurant is serving this dish with this ingredients, I would actually like to make an app wherein, you know, I can enter, these are my food preferences and I'm allergic to this ones. So what are the best food which I can get and which restaurants can I visit to? So this is something which I would appreciate. You know, sometimes I don't want to eat a particular type of meat or, you know, I'm not in the mood for something, but how do I search for that restaurant? How can I find where, you know, that particular dish with respect to my ingredients is served best? Yeah. There is nothing like that. So if we have such data set, if restaurants are okay to provide that data to us, we can surely make it.
Totally, yeah.
Yeah, because restaurants wouldn't want to give out their ingredients right to the public, right?
Definitely.
So.
Some of them have to, right,
yes.
for allergy reasons. But yeah, not everybody wants, they don't want to know their secret sauce.
Yes.
Yeah. Right? Half the time it's mayo.
I think we have a question over there.
Yeah. So you mentioned the data that basically only California, only like existed for like 10 years. There was a lot of parameters. So after taking out all the negative reviews, so how big was your data set? At the end of it?
2 to 3K. Not much.
Yeah, I think 1500.
Yeah,
1500.
around 1500. Since we just took Santa Barbara as our data set as well, so we filtered it down a lot just for an analysis purpose.
Yes.
Also, just a comment, like I noticed you guys said that you want to, you know, think about taking this project further. Another thing that we noticed when we were, you know, riffing through ideas of what we can do with the data set, we found this one thing that with negative reviews, there were quite a lot of reviews that were given on days like, you know, Christmas or like super like festival kind of days and stuff, and they were negative, but they aren't, it's not actually because the food's bad, it's because the service is taking time because of, you know, things that are out of their control because of circumstance. So like, you know, it would be a great idea to, you know, sift those kinds of reviews out because they're not really impactful, they're just sad and aggressive.
Yeah. No, that's actually a good insight. We did not think about it.
That's what
that's good. Yeah.
So, yeah. Thank you.
Yes, to kind of build off of what Ruchi was saying, I was wondering, because you have the polarity scores, you have the aggregated, did you do any analysis to see which restaurants had low ratings but high polarity scores or vice versa?
No, I don't think so. We did that.
No, I don't think so.
With the crunch of the time, we couldn't do that.
Yes.
Actually, yeah.
We just took it out.
Yeah.
I think that's a good point to analyze.
We could have done that.
Rishi, I think you just brought up a cool tool though. If somebody creates it, every restaurant on the planet's going to want it. The one that filters out like obligatory negative scores, right? Ones that really aren't reflective of the food, it's more service related or whatnot. And I think OpenAI is going to be a huge helper for that. So food for thought, my friend. You might have a little profit there if you can figure that one out. Yeah. Good job, guys. It was great.
Thank you so much.
Yes. Yeah, we have
No questions. No questions. So you mentioned time a few times. How many of these tools did you have experience with before the weekend? That was an amazing amount in MLB that happened.
So given a team, I would say all of us had experience in one or the other tool. So as a team, we were able to perform this job pretty easily, I would say. So I had experience in OpenAI, and these guys had experience in Tableau and dashboarding. We had Reveille and Alekia help us in coding, in Python, and all of us joined in where the work was falling behind. So all of us chipped in, and we were able to perform as a group.
Okay, very cool. Can you speak a little bit more about the OpenAI API?
API, yes. So basically, I had been, working with OpenAI API in my research. I work with a professor as well as a research assistant. So basically, what I was doing with his project is I'm trying to identify a particular company which has a good, scope of research and development. So based on CEOs, calls transcripts. After every quarter or after like once in a year, CEO comes up and he says what are his company's plans. So he explained it to general public with respect to his shares, how his share is performing. So my professor had all of this call transcripts with him. So my basic aim was, with related to this transcript, I have to find out if CEO has any ambition for research and development. When it comes to research and development, he was basically focused on AI and ML. I could have done this, with respect to other tools as well. I tried doing it after cleaning the data. I tried doing it with sentiment analysis as well. I did with topic modeling too, with LDN topic modeling. But there was a point where he wanted to, indulge in OpenAI as well, because he wanted to explore that part of the thing. So that is when I was introduced to OpenAI's API. I integrated this and I gave it a prompt to basically identify if there is a hint of, I would say, research or probably, what can I say, research and development, or basically any mention of AI or ML with respect to his text. So this was basically my prompt, and I was asking it to give me an answer in yes or no, so that I can analyze it further. So this I already have pre-built program with me, so I was able to pretty much use it quicker in this project, when I have to just tweak my prompt saying that can you identify which cuisine this restaurant majorly focuses on. And it's actually connected to the internet, so it was pretty quick for us. I would say we had around 1,500 restaurants in that, not 1,500. Yeah, it was like 5,000 beginning, and that 5,000 restaurants, it took like around 4 to 5 minutes to give me the cuisines out of all of those. So it was not.
And it was the reviews that you passed through?
Sorry?
No, the restaurants.
5,000 number of restaurants.
But what was the input or prompt to?
So I basically used
into the cuisine, yeah.
Yeah. So since each restaurant had different number of cuisines, we just wanted to identify a particular cuisine. Probably I would say 2 or 3 for a particular restaurant. So that is when we used